Good morning, my dear students. Today we are going to see Karl Pearson's product moment method of correlation. We have already learned that correlation coefficient is a measure showing the strength and direction of the correlation between two variables. And of course, these two variables should be correlated, and there should be we are talking about linear correlation as well. It was Karl Pearson, the statistician, who first defined correlation coefficient, and therefore the name Pearsonian correlation coefficient. This measure of Karl Pearson's coefficient of correlation is denoted by small letter r. The formula is r is covariance xy upon sx into sy. Covariance, it implies the measure of the direction of the correlation between two variables. That means whether there is positive correlation or negative correlation. The value of the covariance is not very significant, but only the sign, whether it is positive or negative. And the formula of r is equal to, or coefficient of correlation is equal to, covariance xy upon standard deviation of x into standard deviation of y. And what is covariance? Covariance means sigma x minus x bar into y minus y bar upon n. Okay, that is a covariance. So x and y are the two variables, and from x we have to subtract x bar or mean, and from y we have to subtract y bar or mean of y, and the column total or summation should be done, and then sigma x minus x bar should be multiplied by y minus y bar, and then we will get the total of the column, that is sigma x minus x bar into y minus y bar, and that should be divided by number of items n, and that will give us covariance. Okay, now what is standard deviation of x? When variable x is available, standard deviation can be found out by the formula sigma x minus x bar the whole squared upon n. Similarly for y, it is sigma y minus y bar the whole squared upon n. Now what does the formula say? Covariance xy upon sx into sy. Sx is here and sy is also available. So when you apply the equation, what will happen? We can make a formula from that. This way it will appear. That is sigma x minus x bar into y minus y bar upon sigma x minus x bar the whole square into y minus y bar the whole square. N was there, under root n, both under root n's will get cancelled with n, and therefore this is the formula, r equals. So first formula you have to study is this. Now another formula, alternative formula which you can get is covariance x, that is for covariance. Covariance is equal to sigma xy minus n x bar y bar upon n. Okay, where sx is given by this formula, square root sigma x squared minus upon n minus x bar square. And similarly for sy is equal to sigma y squared minus upon n minus y bar squared. Okay, another formula for r is equal to sigma x minus x bar into y minus y bar upon n into sx into sy. If you just take the first portion, that is sigma x minus x bar into y minus y bar upon n, it is actually what? Covariance only. Sx means standard deviation of x and sy means standard deviation of y. So the original formula, covariance upon sx into sy, the same is the formula which is written here as well. Now R is also equal to sigma xy minus n x bar y bar upon n into sx into sy. Okay, where mean we get as a uh, are available to us. Means are available. X bar and y are available. We will apply this formula. Then, if sigma x, sigma y, sigma xy, sigma x squared, sigma y squared, these are available, what we do here is we don't calculate the mean etc. here. We straight away multiply the values x and y, and then we get sigma xy. If we square it, sigma squared, and sigma y squared we get. And that formula can also be used for calculation of r, where r equals n into sigma xy minus sigma x sigma y upon square root of n sigma x squared minus sigma x the whole square into n sigma y squared minus sigma y the whole square. Okay, so these are the different formulae which we can apply to get the Pearson's coefficient of correlation. This particular formula is applied when x bar and y bar are not integers, they are fractional numbers. Then we apply this formula. Okay, if x bar and y bar are integers, then we apply the earlier formula. Now, what are the assumptions of Pearson's correlation coefficient? First assumption is there is a linear relationship between two variables. We assume that there is a linear relationship. If there is no linear relationship, we need not work out the particular question on this. So there is always supposed to be linear relationship. There is the cause-effect relationship between two variables. Correlation is meaningless if there is no such relationship. Okay, so there should be a cause-effect relationship. There should be a particular cause for an effect. And so these are the two assumptions. Please learn it as important. Sometimes this question can be asked in exam for 2 marks even. Properties of correlation coefficient. Also very important from your exam point of view. The value of correlation coefficient lies in the interval -1 and +1. Okay, -1 and +1. So we can say R lies between -1 and +1, that is -1 less than or equal to R less than or equal to 1. Okay, so R lies between -1 and +1. That is the point here. Correlation coefficient is free from unit of measurement. Okay, so when you write correlation coefficient, you don't attach any unit, write a pure number there. Then the correlation between correlation coefficient between x and y and x are the same. Whether x you write first or y you write first, the value will be the same when you calculate coefficient of correlation. Then the correlation coefficient does not change with change of origin and scale. What do you mean by change of origin and change of scale? Change of origin means change by addition or subtraction, and change of scale means change by multiplication or division. So on your page number 69, it is mentioned what actually is the meaning of this. Okay, please read it and understand it. So when you say change of origin, it implies that we have changed the value by addition. When x is added with a particular value or subtracted with another value, then it is a change of origin. Okay, but the correlation coefficient is not affected by this. There may be a change of the values, but the change of positions, relative positions are is not happening. That means relative positions would remain the same. Okay, that is the implication here. Then when we talk about change of scale, what does it mean? We divide or multiply the variables x and y. In that case, there is change of scale. Okay, so when x is multiplied by a particular number, suppose 10, then we can say there is change of scale. Or if 100 is divided by 10, then also there is a change of scale. that way, multiplication and division. Even this, if this happens, then also there is no change in the value of r. So we can say coefficient of correlation does not change because of uh, change of origin and scale. That is the point. Then the correlation coefficient does not change with the change of origin and scale. That is what we have seen. Therefore we can say ruv is equal to rxy. When you change the values of x and y by origin and scale, then we get r as ruv, which is equal to rxy, which is equal to r. Okay, and the last point here is r minus xy is equal to minus r xy. R x minus y is also equal to minus r xy, and therefore if one of the values is negative, then r is going to be negative. If both the values are negative or positive, then r also will be positive. Okay, that is the implication here. So if the signs of both the variables are changed, then the sign of the correlation coefficient remain unchanged. Okay, those are the points which we have to remember. Okay, so please go through these areas and study them well.